In this video, we will see how to construct the perpendicular bisector of a line segment. To construct the perpendicular bisector of a line segment, we need a line, a straight line. We can take a longer line, a shorter line. Let me take a shorter line so that we can clearly see the intersecting arcs. So that's a line. Now, I'll take a pen and there we go. So drawing a straight line. Taking away the ruler or scale, we will level the end points of the line segment. Let the name of the line segment be AB. Let the name of the line segment be AB. So one of the end is A and another end is B. So what is the question for us? The question is construct the perpendicular bisector of the line segment AB. To do the construction, we need a circular. Sometimes children call a circular as a compass. That's okay. Call it by whatever name, but it is a circular because you can draw a circle out of it. Now placing the pointer at A, pencil of the circular at B, we have measured the full length of the line segment AB. To construct perpendicular bisector, we need more than half of AB as a radius. So I shrink the distance between pointer and pencil. There it is. Now this is approximately more than half. Now we'll place the pointer at A and above and below the line segment above and below the line segment AB, we will draw intersecting arc. There it is. That's one and that's the next one. So the intersecting arcs. Now the pointer goes at B. The pointer goes at point B and we will cut the previous arcs. We'll cut the previous arc. So now the pointer at B and I'm going to cut the previous arc. That's done. And this one. Fine, we got the point of intersection. Now we don't need the circular. Take the scale and we have to place the scale between the point of intersections. We'll put the scale between the point of intersections perfectly, correctly we'll put, so that once I join those two point of intersections with the dotted lines, the point where this line intersects, AB, our given line segment, that becomes the midpoint. Let me do this properly. There you go. It should be carefully done. That's why. There you go. Now I take a sharp. Okay, now we go for dotted lines. We need only dotted lines. Just ensure that we have a dot on the line also, the line segment AB, that. Okay, and these dotted lines, one of them went aside, but I'm perfectly tracking on this. So it's perfectly done. Now we don't need the circular, we don't need the scale or the ruler, and there you are. So we got a line. I just name this line, the line as PQ. That point is P and the bottom point is Q. So the line PQ is perpendicular as well as bisector of AB. So let the midpoint of AB be O and PQ is perpendicular. So this is how we construct perpendicular bisector. But let's measure that whether it is really perpendicular or not. For that, I'm taking a protractor. I'm placing protractor perfectly at point O and the base perfectly aligned with line segment AB. And as I turn the handle of the protractor, let's see what angle it reads. Wonderful. it has a red perfectly 90 degree. That means line PQ is perfectly perpendicular to the line segment AB. So PQ is a line perpendicular to AB. That was the first part of construction. Now let's check whether we have really constructed the bisector or not. To understand that, I'll take the circular and I'll place between point A and O. I'll place this between point A and O. A little bit above I'm putting so that we can clearly see the location of the pointer and pencil. That is it. Now, O will be the midpoint of AB if OA and OB are of same length. So OA length is this much. Let me put the pointer and pencil between OB. See, it is of perfect measure.
Hence, PQ is perpendicular bisector of AB.